When we want to graph a rational expression, we need to know some important key features of the graph, such as where we cross the x and y axis and where we encounter asymptotes. And there are other features as well, but for this video we will be discussing asymptotes. An asymptote is kind of like an invisible line which the graph comes close to but doesn't cross. There are exceptions to the rule, but we don't need to concern ourselves with the exceptions in this discussion. Let's just make a random graph and demonstrate what an asymptote is. I can have vertical asymptotes, I can have horizontal asymptotes, and a graph that had these asymptotes may look something like this. Notice how the graph comes along and sees a wall and has to turn aside. The graph comes up on the other side of that asymptote, sees a wall ahead, has to turn around and go back. This graph is coming along here, sees a wall, has to turn aside. We can also have slant asymptotes. So we have a slant asymptote like that, and a vertical asymptote like this, and then our graph may look something like this. So to make our graphs, it helps to have in mind some of the rules that we need to know for finding vertical and horizontal and slant asymptotes. Let's start by talking about vertical asymptotes. That's the easiest. When we have a rational expression, which simply means we have a polynomial divided by a polynomial, we first of all want to see if we can simplify by factoring and canceling anything that will cancel. I'm assuming that you already know how to factor, so I'm not going to go into the details of factoring, but this numerator factors like this, and the denominator factors like this. And notice that we have x minus 2 on the top and on the bottom. Those can cancel. So our simplified rational expression will be x plus 3 over x plus 1. Now we will set our denominator equal to 0. So our vertical asymptotes will be where x equals 0 and where x plus 1 equals 0. If we solve for x, we will have x equals negative 1. So we have a vertical asymptote at x equals 0 and a vertical asymptote at x equals negative 1. Now you might think we would have a vertical asymptote where x minus 2 equals 0, or rather simplified where x equals 2, but we actually don't have a vertical asymptote there. We just will have a hole in our graph. So these are the vertical asymptotes. When we talk about horizontal and slant asymptotes, we have several different scenarios we have to consider. But the first step is always the same. You have to compare the degree of the numerator with the degree of the denominator. And when you do that, there are 4 possibilities. If the degree of the numerator is less than the degree of the denominator, it will give us a horizontal asymptote whose equation is y equals 0. Let's look at this example. What is the degree of the numerator? Remember, the degree is the highest exponent. The highest exponent is 2. In our denominator, the highest exponent is 3. So the degree of the numerator is less than the degree of the denominator. So we have a horizontal asymptote at y equals 0. Now we could have the degree of the numerator equal to the degree of the denominator. Then we will have a horizontal asymptote of y equals the lead coefficient of the numerator. Remember, lead coefficient means the number in front of the variable that has the highest power. So our lead coefficient here is 2. Our lead coefficient here is 3. So we have a horizontal asymptote at y equals 2 divided by 3, or 2 over 3. Okay. So our third case, we can have the degree of the numerator greater by 1 than the degree of the denominator. Here our numerator degree is 3, our denominator degree is 2. So this is 1 higher than this. To solve this, we have to do polynomial long division. I'm hoping you remember how to do this. If not, you may want to review polynomial long division. The number on the bottom goes outside the box. The polynomial on the top goes inside the box. Okay, so x squared goes into x cubed x times. Multiply this times this gives me x cubed plus x squared minus 2x. If we subtract this minus this, that goes away. 2x squared minus x squared is x squared. Negative 5 minus negative 2 is negative 3x. Bring down the negative 6. X squared goes into x squared 1 time. Multiply. Subtract, that goes away. That gives me negative 4x minus 4. I'm finished. This is my remainder. We ignore the remainder. We will have a slant asymptote at y equals the quotient. The quotient is the answer, x plus 1. And our last possibility is if the degree of the numerator is greater by more than 1 than the degree of the denominator. In this case, there is no horizontal or slant asymptote. So in this case, we have the degree of the numerator is 3. The degree of the denominator is 1. There's a difference of 2. So there is no horizontal or slant asymptote in that case.